Hello everyone, my name is Zylinski, and today I'll be going over my question for the project of how does the average income of a zip code affect the average score of a restaurant. So as you may know, we're using the restaurant inspection grading dataset, and I decided to merge it with the income per household dataset of New York City. This was to ask the question to see if whether wealthier neighborhoods have restaurants with a higher grade on the inspection scale. So first, I'll take you through some of the data preparation that I have done. Initially, I uploaded the restaurant data, as you can see here, into Jupyter Notebook, which is where I did most of my cleaning. I did info just to ensure that it was loaded in properly. Next, I loaded in the income dataset. So the income dataset came from the IRS tax returns, and it was actually a very messy dataset. As you can see here, it has the zip codes on the left side, and then it repeats the zip codes for each of the income brackets, and it has over hundreds of different columns. However, the only thing that I actually needed was total income, amount, and number of returns. So I decided to extract those two columns along with the zip code and create a new field that divides the amount by the number of returns for the total of the zip code to get a average income for that zip code. So you can see here, I also checked income.info just to make sure everything was loaded properly. And these data sets are very large, and I still need to do some more data preparation on them. Here I'm creating a smaller income data set just to work with less data. And this is probably the most difficult and challenging part of data preparation. So what I needed to do was basically drop all of these irrelevant zip code records, because the only one I needed was this total one. And the way I did that, after trying many different things such as lists and putting in dictionaries, was to run a for loop through each file of the data frame, which is smaller income. Then I realized that the total zip code repeated every 8 rows. So I did if the index is modular 8 does not equal to 0, meaning if it cannot be divided equally into 8, then it's going to drop that from the index. And after this, I was able to get a cleaner dataset which only had the zip codes that I needed. After this, I connected the restaurants dataset as well as the new income dataset, and I did this on the field zip code. And this is the resulting output of it. As you can see, everything is put together, and here's the average income field. Next, I created a short connect just to have a smaller data set so I could be working with less data. Now, another very important step in the data preparation process is to group. So what this means is for each zip code and average income, give me the mean value of the score. And the score is, of course, the violation score that a restaurant receives. The lower the score, the better the restaurant. And this gives you that zip code, the average income of the zip code, as well as the average score for all restaurants within that zip code. Now after this, so this outputted a series, and I had to change it to a data frame so I can use it for further analysis. By the way, whenever I was stuck with any of these problems, I used either Stack Overflow or this pandas.org website. And this is the resulting data set, the data frame that was created, which gives me zip code, average income, and average score. And after this, I downloaded it into a CSV file so that I can use it for further analysis. Now I open up my Spider notebook. What I was plotting was, for the spider file, was the average income on the x-axis or the horizontal axis, and trying to see if that could be a predictor for the response variable or the average score per zip code. So this is pretty similar to the Gapminder assignment. I use the burrow as a slider, and this will give user control so that the user will be able to select which burrows they want to see. And the rest is pretty standard. It was just labeling the x-axis, the y-axis, and then running it. So after I ran it, this is the plot I received. So as you can see, all of the points seem to go around have a mean score of about 20, maybe 18.5, 19. And here you can see the average income of the zip code in thousands, of course. So even though here there are some very rich zip codes, their restaurant score is similar to these lower income zip codes, which means that there's no correlation or very little correlation based on this data set that we have been using from average income to the average restaurant inspection score. And here is a slider. So when I have it, this is for the entire data set. When I move it to 1, it'll show me for zip codes in Manhattan. If I move it to 2, it will show me zip codes in Brooklyn. For 3, it will show me Queens. And for 4, it will show me in Staten Island. And if I go back to 0, it will show me for the Bronx. Thank you guys for listening to our presentation. And if you have any questions, feel free to comment or email us or anything of that nature. Thank you.